Hello again, and welcome to today's webinar, The Observability of Quarkus Applications. My name is Kristen Brown, and I'll be your moderator. Today, we're excited to have Josh Lee, Developer Advocate at Instana, and Marco Bungart, Senior Software Engineer at ConSol. Before I hand it over to our speakers, I have a few housekeeping items to cover regarding this webinar. First, today's webinar will be recorded and available on demand after the live session and will be sent to you via email, or you can access it through our website. We'd like to hear from you during today's presentation. If you have a question for our speakers, please feel free to send it through the Q&A box on the bottom of your screen. We'll be answering questions throughout the session. If we don't get to your question during today's webinar, we will be sure to follow up afterward. So without further ado, I'd like to kick things over to our speakers.
Hello, and welcome. So, Josh, why don't you go ahead and present yourself to the audience?
I'm Josh Lee. I'm the developer advocate here at Instana, and we'd like to show you a little bit about monitoring Java applications with Quarkus.
And my name is Marco Bungart. I'm a senior software engineer at ConSol, and we are going to split this talk a little bit into three parts. One part will be a little bit of a theory session about what is observability, what should we observe, why should we observe, and so on. The second part, since talk is cheap, is a demo locally. So we are going to show you how to set up an observability setup on your local machine. And the third part is showing you how it's actually running on the cloud. And with this, we are getting started. So observability, we are going to answer 4 key questions for this. Why should we observe? What should we observe? When should we observe it? And where should we observe it? And we are going to start with the why. So Robert C. Martin once said, the only way to go fast is to go well. Yeah, so in software engineering, we already learned that going fast means going well, but the same thing applies for our application when it's actually developed and running, because in order to handle our application in production, we actually need to know what our application is doing and why it's doing it. And that's where observability kicks in. Yeah. So the normal development life cycle, for at least at me, looks something like this. Normally, I develop on my local machine in my local dev environment, typically Docker setup. Then when I'm done, I'm going to push it to the pipeline. The pipeline is running. When the pipeline is green, it gets deployed in E2E or QA environment somewhere. And when E2E and QA are satisfied, it's going to get pushed into production. Yeah. So first thing is we should observe everywhere we can in the stages. Yeah, pipeline is observed already, because if the pipeline fails, we normally get an email and we see something is wrong. But more crucially, what most people don't observe is the E2E and QA part. So of course, with our E2E tests, we know when the tests are failing, but why the tests are failing is the more interesting part, because we need to fix it. Also, if we have a QA environment and QA comes back and says, okay, here's something is clearly not working. It should be this and this, but it is actually that. We need to figure out why. And this is a crucial step that we don't only observe into production, but also observe in E2E environment. So this gives us the benefit, if we start observing, that we are switching from first from reactionary to reactionary with a warning. So we might see that something is failing, and before we get the actual alert or the actual issue, we already see something is going wrong. We can start reacting to this and improve. This gives us a little bit of leeway in response time. But even better, if we start observing on a more granular session level, we are able to switch from reactionary to actionary, meaning we can actually see the problem coming and act before our end users actually see what's happening and can fix it. So another key feature we want to introduce is when we shift the observability left, so left closer to the dev environment, we can get to a point where we don't act actionary, but we can fix the problem before it actually becomes a problem. So if we are able to observe the behavior of our application and the misbehavior of our application, for example, in QA or even on our local dev machines, we can fix it before it goes into production. And that is the actual goal. Because remember, if we want to go good, if we're going to go fast, we have to go well. And this is one part of going well. Yeah. To draw a little bit of a different analogy, Robert C. Martin once answered the question of why OO is so successful, and he said polymorphism. It let us point the compile time dependency against the flow of control. Yeah, and here we have something similar. By shifting left our observability, we are shifting against the flow of our application in its life cycle and pushing it earlier. So we can see our problems earlier arising, we can address them, we can fix them, and they don't become problems that we are facing in production. So I think this should cover the part of why we want to observe. So
I see that there's one hand raised. Do we have a question?
Yeah. Do we have Kristen?
I don't see a question, but if you guys want to just throw it in the chat or in the Q&A box, then we can answer it live through that, but I don't think you guys can speak on this webinar.
Okay.
I'll give it a little bit time. Maybe the person raising the hand is typing right now.
Might have just been a mistake.
Okay, then let's continue. So now that we know why we want to observe, now the next question is, what should we observe? So in general, our observability has three main components. Yeah, the first thing are the logs. I think everybody is familiar with them. The next thing are traces, tracing information. And the third thing is metrics. And we are going to take a look on each one of them. So the logs are actually your source of truth. Yeah. Whenever you want to know something about your application, the logs should always be the source of truth where everything is recorded. Yeah. This means we should spend some time designing them. So we should have clear guidelines. What do we want to log? Do we have correlation IDs? Do we want to use correlation IDs? When do we transmit them to other systems, and so on? Also, if we have a distributed architecture, and let's face it, most of us probably have a distributed architecture with micro services, we also need distributed logging. Because if we are running, for example, on a Kubernetes, we treat pods like kettles, not pets, meaning if the pod is gone, everything with it is gone. And most probably the logs are gone as well. And we want the logs for analysis later on if something goes south. Also, tying in the concept of spending time designing logs is we should use structured log. For example, we should enhance our logs with meta information. Yeah. For example, if we have correlation IDs, add the correlation IDs to the meta information of the pod. If we are running on Kubernetes, we should add the Kubernetes pod name, the node name, everything we can to the pod to possibly identify the problem. Next part is tracing. Logs alone are insufficient. They hold the truth, but they are missing the context. Yeah, if you are thinking about a distributed system and you see that something is failing somewhere, it's hard to analyze, okay, why is it failing? What was the context? What was triggered? What was the business case? That's where tracing comes in. Tracing allows us to see what service did communicate with what other service. So we get context to the one event failing. We see what's going on, when it failed, and what failed exactly. The standardized format for this is open tracing. And we should integrate the information we have in our tracing with our logs. For example, if we use open tracing or open telemetry, there's a concept of span IDs that defines a communication over multiple services, we can include the span IDs in our logs. So if we see an error message in the logs, we have the span ID, we can go to our tracing system, say, okay, show me the span ID, and we should see the whole communication to be able to analyze what was actually happening. And last but not least, we have our metrics. Yeah, metrics answer the general question, how is my service doing? Is it healthy? Is it ready? But also things like, what are the response times? Are the response times rising or falling? What are my failure rates? And so on. Yeah. Based on this, we can configure automatic alerting. For example, if I see a rise in response time or a rise in error rate, maybe I want to raise an alert in form of an email to some ops guys so they take a look. Also, through analysis of the metrics data, we can fine-tune our application. For example, if we have a Java application and we see that the memory consumption is too high, but we suspect that our application can work with less memory, we can fine-tune garbage collection and memory spaces. Yeah. Generally, this is a technique to get ahead of the curve, because in the metrics, most importantly, we are able to see problems before our customers see them. And so we get from this reactionary to the actionary stage. And the de facto standard here is Prometheus for scraping. So Prometheus is going to collect the metrics data from our applications, and most probably a front end like Grafana for visualizing the data, because let's be honest, we don't want to see number columns. We want to see graphs and want to be able to visualize all of this. Okay, so now the question of when should we log? By the way, are there any questions so far, Kristen?
We just got one.
Okay.
It was just about the deck being posted, so no real questions.
Jose asks,
no, there's one in the chat. You're right.
can we analyze the database and middleware?
Good question. We'll see that in a minute. I'll postpone this part to the demo time, because we will see, yes, we can. At least the database. Regarding the slide deck, we can provide the slides afterwards. That's no problem. So let's answer the question of the when. Yeah, when should we log? Whenever possible. But please keep in mind, there ain't no such thing as free lunch. Yeah. So observability costs us mostly in terms of computational time and or network traffic. For example, if we log a lot, the logs have to be produced, and if you're using a log aggregation software, they have to be sent to the log aggregation software, or a piece of code has to aggregate them somewhere. Same for traces. Traces have to be collected and sent. Metrics have to be scraped. So keep this in mind, since observability is an awesome thing, but we don't get it for free. We have to pay for it somewhere. Apart from this, going back to the defining of your logs and what you want to log, define clearly what is an info, what is a warning, what is an error. Yeah, so if you produce too much warnings or too much errors, this will raise false positives, and raising too many false positives will in turn lead to blindness. Yeah, you are not going to react to alerts anymore, and this is a really, really bad thing. This can get you in trouble really quickly. So define clearly what is an info, what is a warning, what is an error, and also define in which situation what information do I actually need, especially what information do I need to solve the problem. Yeah, that's important. So a little bit of tales from the battlefield. If you log too much, for example, this just happened to us last week. We were logging too much. We were using FileBeat for scraping the logs from the container. And in Kubernetes, the logs are actually written to a temporary file. And if you create a lot of logs, and we created a lot of logs for debugging purpose, this counts to the hard disk limit of the container. And the one container was actually blocking one entire node because it wrote gigabytes of data to the temporary file. Yeah, so keep this in mind. If you sample too much when you're trying to trace, this can result in bad response time, since every trace has to be sent, every data for the trace has to be collected, and this is pressure on the application. If your health checks are too frequent and have large timeouts, and maybe your application is already under load, there's some infrastructure part doing this health checks, doing these calls. Yeah, and if this part has to wait on every call for maybe a second or two, and you have to do hundreds of checks per second, this can block actual workload from being deployed on a cluster. Yeah, because even the infrastructure is using some work. There are techniques around this, but keep this in mind. So now the question of where should we log? Circling back, we should never hold anything that's mission critical local. Always centralize them. As I said before, pods are kettles, not pets. If a pod is unhealthy, it gets replaced, it gets deleted. Everything in it is most probably gone. We don't want mission critical data to be gone. So we want to centralize them. And also, this is really, really important. If we centralize our information, we have the opportunity for correlation and, most importantly, context. As I said before, seeing one line in the log is not what solves the problem or what will give us a clue of what is going on here. What is giving us a clue of what is going on is the context or everything is happening. So I have to see what triggered this request that went south. If I see the context, I can infer which use case this is, and I can then infer what is the root cause of all of this. And this is really where Instana shines, because Instana has all this information already centralized and is able to give us some context. Yeah. So far, are there any questions, Kirsten?
Not yet.
Okay, then let's talk about Instana, because that's one part we are going to talk about. Instana has all this information, and Instana is able to collect the logs, the traces, and so on and so forth. And with this information, Instana can, for example, show our deployment landscape in a dependency graph. You can see what service is communicating with what other service and how they are communicating. Instana also scrapes metrics information for us, not only metrics information, but also application insights. And through the metrics and application behavior, it can create smart alerts. Yeah, so it's doing this through an AI. And this is a really awesome feature because we don't have to configure anything. Instana learns how the application behaves normally and can then detect abnormal behavior. Metrics are collected every second, and this gives us real-time data of our application. So if, for example, memory spikes in an application, we will see it instantly and we can react instantly because Instana will alert us instantly. Alerts can also create incidents, and incidents in Instana always are treated as root causes. So we already most probably see in Instana what is the root cause, what is going south, and can start analyzing it. That's all done for us. We don't have to configure anything. Yeah, and this circles back to the concept of Instana correlates the data for us. Yeah, correlation and context is the important thing. So, what more? For many runtimes, Instana provides all of this automatically through agents. So we don't have to configure tracing or logging ourselves or metrics information. Instana is able to hook into our application and just collect it for us. A lot of features surrounding logging are right now in the development. So, for example, Josh, correct me when I'm wrong, but I think you guys are working on not pulling the logs yourself, but actually integrating with ELK. So ELK is one for a very popular logging framework. And instead of writing everything from scratch up, you can continue using your ELK stack and just tell Instana, okay, pull your data from there. Is this right?
Yes, so we can link to the ELK stack so that when you're examining a specific service in Instana, a trace span or something like that. If you are using ELK for your logging, we can take you directly to the relevant logs from whatever you were looking at in Instana.
And we are going to see this in the part when we show the application in the Kubernetes cluster.
Yes.
And it looks like we do have 2 questions.
Yeah, please go ahead.
Okay, what is the overhead for collecting metrics every second?
So collecting metrics every second means in Instana calling one endpoint every second. That's your metrics endpoint. And this heavily depends on how you calculate the metrics. So if you're using basic metrics, for an example, by Java applications JMX, it's not very expensive, but if you have to do some heavy calculations, this might take some time. Yeah,
Okay.
It heavily depends on how your metrics are structured. But for normal metrics, it shouldn't be too expensive.
If you don't have any synthetic metrics like Marco's talking about that need to be calculated, you wouldn't notice the overhead.
Okay, and then the second question is, does Instana have capability to read through the data that passes between services?
Yes. We're going to show that.
All right, and then the third question that just came in, can you please explain more about the context part of Instana?
I think that's something we should see in action, actually, because it's if you see it, you know what we mean.
Yeah. But to kind of explain the challenge, so this is a problem that I've run into. I'm sure you have, Marco, other developers that I've talked to have this problem where you're trying to debug something and you have logs in one place, traces in another place, and maybe metrics in a third place. So you're trying to correlate across all 3 places. Maybe the problem is only coming from a specific pod or a specific deployment in a specific pod. And you don't want to filter through all of your log messages just to find that one pod. You want that to be done for you when you found that was the issue, say looking at your traces, or maybe you have a host that has a resource utilization problem and that's coming in through your metrics. And you could then from there see all of the deployments on that host.
And then the last question before I let you guys move on is, what is the maximum age of data that Instana keeps?
That is a good question that I should know the answer to. I know that our 1 second granularity, I believe, is for 24 hours. And once you get into historical data, there will be some warnings on the dashboard that you're dealing with historical data with a different granularity than the most recent data.
But we'll follow up with a more definite answer, Randy. No problem.
Awesome. So a final point on Instana, it can be installed on-prem and using SaaS. We are going to demo the SaaS part today. So Instana is installed somewhere by Instana, and we are going to trigger it. And with Instana, you not only can monitor backends, but also, for example, websites and mobile application. And with this said, I'd like to quote Torvalds on this. Talk is cheap, show me the code. So we are going to jump in the Java code. Let me start by showing you guys a little bit of the application we are going to demo today. The application is a little bit similar to what AWS S3 is doing. So the main gist of it is you can upload data, and the application is meant to upload a lot of data, big data. And instead of uploading it all in one request, the idea is, okay, we make one call to start the request. Response is some request ID. And then we can start uploading parts to this request. The uploads can be in parallel. They don't have to be in order. You just pump them to the backend. And somewhere down the line, you're going to tell the backend, oh, by the way, this upload is going to have, for example, 20 parts. And when these 20 parts are have arrived, the REST API is going to notify an aggregator service through, in this case, an ActiveMQ message channel. And the aggregator service is then going to pull all these parts, put them together in a file, and write them back to a database. And finally, our users are able to download the data. So that's the application we are going to demo today. I'd like to show you guys my local setup. That's actually one Docker Compose file. You see up here, we have defined our two services, the one REST API service, and then here the aggregator service. And then we have everything we need down here. For example, this is a test that's not relevant. This here is our database we are using. This is a UI2 database. This is our ActiveMQ that we are going to use. And here's the interesting part. We have a Jaeger for our tracing. We have a Prometheus and a Grafana for our dashboard. And we have an ELA stack for our log aggregation. So, and with this, I'm going to demo you guys the application locally. We are going to make one round trip through the application. And we are then going to look at the logs and the tracing and so on. So we start by saying we want to upload a new file. I'm going to call the correlation ID foo. I will keep this right here constant over all requests. So we will be able to see all requests with this correlation ID later in the logs and the trace and so on. We are going to start the upload. Oh, new upload ID is 2. Awesome. Then we are going to post one part to this upload. This will be my trusty little penguin right here. And since this is a small file, we are just going to say, okay, and this is it. Upload number 2 has only one part. And we see right here, it's now showing, okay, upload is still in progress. But when I go up here and say, okay, get me the upload with the ID 2, not 21. We see in the background, something has happened. Our upload is done. And we can finally say, okay, please get me the upload with ID 2. Correlation ID is again true. You can download the file here and way, it's our trusty penguin. So that's the boring part. Now comes the interesting part. This here is my Jaeger instance, and it is running in the background. So my application has, during all of this, sent trace information to the Jaeger backend. And the interesting call is this call right here. Yeah, this is the call that, let me switch back to the overview of the application right here. This is the call right here. So one of these calls triggered this detection here. All parts are there. And then a message was sent down to the aggregator, and the aggregator did some stuff. And this is what we actually see here. So let's take a look at it. We see, okay, this here was a put request. See, it's up here. There was the question of can we monitor infrastructure? And yes, we can. For example, we see right here, this request triggered a database query, and we are able to see the query right here. We don't see the parameters, but we see the exact query. And we actually see, okay, that's not one query, 2, 3, 4, 5, 6 queries, 2 queries, 1 update, 2 queries, 1 update. Then right here, we see a message has been sent out. Yeah, we see it in the graph right here perfectly fine, since here is a break. Here, the message was received by the aggregator service and it started working. And on this side, we also see, oh, look here, here's a database query, here's a query, here's an update, and here's another update. So we are able to see the whole request with its trace information. Now, let me switch over to my log aggregation. And here I can say, okay, please show me everything with correlation ID. Yeah, come on, not this one, but I used correlation ID foo. And now I'm going to see right here, okay, those are all the log information I have on correlation ID through. I'm able to filter through them. I'm able to see what's going wrong. If I'd like to choose so, we'll see that in the cluster, I can filter down on the specific pod that generated this correlation ID or this singular log. If I know, for example, something in the aggregator went down, I can say, no, I don't want to see everything, because this here is actually everything from both containers. So the REST API and the aggregator. I can filter down to only the aggregator. And finally, I want to show you a little dashboard. So this here is mostly base configuration from Quarkus. You just have to add one extension and you are already able to see, okay, what's my JVM usage? So what memory section needs how many memory, how many megabytes. Here we see the CPU load and the number of requests. Right here's a spike. That was the time when I started uploading. And I'm, of course, able to switch between the aggregator service and the REST API. So that's the local setup. And now let's actually see all of this in production. And for this, I'm going to throw it over to you, Josh. Or are there any questions, Kristen?
So I've been trying to answer the questions as they've come up in chat, but if anyone has, if anyone needs clarification on any of my answers, I'm happy to go into that. Is it supported for Windows 2008? Don't know.
Okay, if there aren't any questions, then I'm going to throw it over to you and you can demo the part for the actual live installation.
Yes.
For those of you interested, the application is running on an AWS EKS cluster, and Instana, the Instana instance we are using, as we said, is running on the Instana side. So we are sending information from the EKS cluster to Instana.
Okay, so I see a few more questions. Does Instana monitor application logs for applications hosted on a regular VM? Yes, absolutely. You can install the Instana agent on your VM, and it will monitor. Basically, once the agent is installed on the host, the sensors will detect what compatible technologies are running on that host. It's a very, very long list that you can see in our documentation. And it will automatically install the sensors required for any of the compatible technologies running on that VM. The other question I see is, any advantage by integrating to Grafana? As in, no. Unless you want to view your metrics in an environment that's not instrumented with Instana, there isn't. I don't think there's really an advantage to using Grafana. I could be wrong. There might be use cases where you need that, but from my point of view, Instana gives me everything that I could ever want.
Okay, 2 more questions came in. Is it supported for Windows 2008?
I don't know. I'm gonna have to get back to you.
Okay, and then does applications still need to do logging as they do today?
The application still needs to output logs. Yes. I mean, Instana won't know what's going on if your application isn't outputting any logs, but Instana will pick up those logs, even if they're just like, if you have a Docker container that's just logging to the standard out, Instana will pick up, I believe, any warning or higher logs that end up in that output. So we'll pick up the logs wherever they go, but your application will still need to actually be outputting logs.
Okay, and then another one. Can you share a deployment guide for Instana on OpenShift?
Yes, but I will need to get back to you about that. I don't know if we already have one prepared.
Perfect, thank you.
Maybe a little side note. On the last slide, we are going to see this in a moment. The source repository, as well as the infrastructure repository that we use to deploy all of this, is linked. And within the infrastructure repository, you also have the deployment of Instana agents. Yeah. But that's for Kubernetes, not for OpenShift.
Yes. And then there's another question. Tanzu, yes, we'll figure out exactly what needs to change with our example for those environments. Okay. So let's now dive into the actual Instana tool. I'm going to share my screen. Okay, so actually we should start on the homepage, but this environment is actually an environment that we use for a number of things. Some of our devs are running proofs of concept that are reporting data back to, this is an Instana SaaS backend. You can also install on-premise if you want to be collecting all of your data on-premise and not sending it back to our SaaS. This is a more complicated installation process, of course, but it is supported. And so in this environment, we have all of this data coming in from various agents installed on various platforms. There's one running on my laptop right now. But to cut through all of that noise, the first tool that we're going to look at is application perspectives. So application perspectives are really just a way to filter out all of the information that's not relevant to you. This is especially useful, if you have teams that are interested in certain services but not others that make up your overall service. So for example, for this project, we've defined this application S4, which is the application that Marco was just demoing. And we set up just a simple filter. The demo gods are not shining on me today. But if that screen had loaded, you would see that this is just set up to filter for data coming from some specific ECS hosts where our EKS cluster is running. So we can see there was the question earlier about Grafana dashboards and also metrics. So here we can see this dashboard. I didn't need to configure this. I didn't need to set any of this up. We just installed the agent. It saw what was interesting, and it's presented us with this dashboard. So I think this is way better than editing YAML and managing Grafana dashboards. I alluded a little bit to the automatic sensors. So that's another huge benefit of Instana, is that if you're using compatible technologies, you really need to do almost no configuration. You'll install the agent on all of your VMs or as a sidecar container in Kubernetes or Docker, and you'll just start to get the data that you want. I'll real quickly show, this is from the repo that Marco was alluding to that will be linked. So this is the complete configuration for Instana for this app. And so you can see we have a little bit of configuration for the Artemis MQ, just telling it Instana which queues are interesting to us. We are using some customization to the Prometheus metrics to gather some of the synthetic metrics that the Quarkus application is outputting. If you're just looking for host level metrics and you're not looking for any custom metrics, you won't even need this. Instana will just pick up those host metrics for you. We need to give Instana admin access to our Postgres database so that it can profile that correctly. And we're enabling OpenTelemetry tracing, which we're very happy to now support, so that you can gather tracing from environments that are not compatible with our auto tracer. So our auto tracer will instrument a large number of environments. Again, you can see the full list of compatible tools and frameworks on our documentation. But if you are using an incompatible framework or a language, then you can submit OpenTelemetry traces, and Instana will happily chug along with those. So getting back into the dashboard. There was a question I said we would get to about the communication between the services. So yes, this is really one of the major benefits of a tool like Instana. Tracing libraries are great for tracing, instrumenting a single monolith application. But when you get into distributed tracing, where you have a single call may trigger a succession of calls to dozens or even hundreds of services, how do you keep track of that? And Instana will do this for us. So if it ever loads. Okay. This is what we get for doing live demos.
Should I take over the screen? I think.
Yes, I think this. I think this is my internet and not Instana. So Marco, if you want to take over, please do.
Here we are.
Excellent. This is what I wanted to show. So the communication, you saw the configuration file. I just showed that a moment ago. We didn't tell it anything about what services communicate with what. We didn't even tell it anything about what services we have. These are just the services that were picked up by the sidecar container. It sees that they're talking to each other, and it's able to correlate all of these calls and give us this graph of which services talk to which. So we can see here that we have the REST API app, that's the Quarkus application, communicating with the AMQP queues on the Artemis, and then sending those to another application, and finally that ends up back in the Postgres database, which is read out by the REST application again. And so this was all automatic. We don't need to do anything to instrument this. We can analyze these calls down to, we can see, for any one of these requests, what the origin request on the REST API was, and so on.
It looks like you just got a question, Josh.
Okay.
When saying it auto discovers the service, is it not required for any code update at all? Correct.
You don't even need to restart the server. So if you have a Kubernetes cluster with some services running on it, you can deploy the Instana agent and start receiving data in a few seconds. And that's another important feature that Instana has that I don't believe any of our competitors have, which is we have the 1 second granularity, which is great. I think that's, with the speed at which applications move today, 1 second granularity I would consider a must-have for real observability. And on top of that, we have 3 seconds to notify. So what that means really is that all of your data on this dashboard it's only 3 seconds old. So you can make changes to your infrastructure, you can make changes to the Instana configuration, and see those changes reflected here immediately without any restarts, without any redeployments, and yes, without modifying your code base at all. For languages and frameworks that support auto tracing, you can also get those traces without any code changes. Okay, so here we can see the flow of calls between all of the various services. And let's see if it's loading for me yet.
In the meantime, should I show our audience the trace information we formerly saw in Jaeger here?
Yes, please.
Okay, awesome. So let me get the right endpoint. I think it's this one right here. Exactly. Here we are.
So here you can, yeah, this is great. Thank you, Marco. So this is a complete distributed trace. So just like Chrome will do for our front end profiling, here we have a complete profile of the backend request across all services and back again to the API server. And as your architecture changes, as you add new services, remove services, change which services talk to which, you won't need to modify any of your configuration. You won't need to modify your code at all. Instana will just follow the flow of requests. The other thing I wanted to talk about is smart alerts.
So just tell me where to click. I'm going to click it for you.
Yes, but just to drive it home, Marco, would you be able to turn off the Artemis server?
Oh yeah, of course, I like this. So it's off.
Okay, we also have a quick question.
Yeah.
Is Instana still relevant for clients who don't use any K8s and are only on-prem?
Yes, absolutely. Absolutely. You install the host agent on your bare metal, on your VMs, wherever it is, and it will work the same way. You'll still benefit from the automatic service discovery and automatic instrumentation of any supported technologies. You can install it directly on Mac OS, on Windows. I'm not sure which versions, but I'm going to check. On most Linux distributions, on IBM ZOS, and it's a Java application. The agent is a Java application, and it will use its sensors to detect what you're running and install all of the necessary plugins.
So do you want me to go to the dashboard again?
Yes, please. Oh, look at that. We're starting to get some error calls. That's weird. So what could possibly be happening? Again, I do want to point out Marco has this in live mode, which means that we're seeing the data stream into this dashboard as it's coming into the Instana backend. And another nice feature about the time filter up there in the top right is whatever settings you put in there, that will hold as you navigate throughout your applications and services and the various entity screens inside Instana. So that's really useful. Like we were talking before about the correlation benefit. You know, say you're trying to debug an incident that you know happened between 107 and 109, you can put in that time window, and that's saved as you go through your traces, your logs, your metrics, and everything.
Okay, Josh, we have 2 more questions.
Okay.
Let's say there are issues in database. Does Instana provide the details DB monitoring tools provide, or just a high level? Is there an issue within DB?
I'm not sure I understand the question.
That's in the Q&A box if it's.
Got it. Thank you.
Read it. Yep.
You would be able to see, I think, which queries are having issues. You'd be able to see increased latency and which queries those are on. I believe you would be able to see log messages from the database service. Guy, I see that you were asking for clarification on the question. What was your original question again? Oh, I see, it's under-answered.
Do you see it? Is Instana still relevant for clients which don't use any Kubernetes and are only on-prem?
Yes, yes, definitely.
So one thing, beautiful thing about Instana is you don't have to run on Kubernetes. It is one platform supported, but you can also install it for example, as agent on your bare metal host if you don't run Kubernetes or anything like this. And it will just work the same way.
And then there's another question over in the chat. You mentioned earlier Instana is able to read through the data services. How do we search/filter for users affected by a certain service that has failed on a specific moment in time?
Excellent question. So for this demo, we've only instrumented the backend of an API, but Instana also includes end user monitoring. So for end user monitoring, there's just a small JavaScript snippet that you would install in your front end website, or if you have a mobile application, there's an agent that you can install there, and then you will get full end user monitoring, and the traces that come into Instana will have the context of the front end action essentially that kicked off that entire chain. So then you can use that information to do things like filter by the user's location, or any other data that you might be collecting about the user from the end user monitoring. It's a little bit outside the scope of this example. Oh, look at that. We have an issue. So one of the things that Instana has is expert knowledge built in. And this is a combination of us just building in common sense things that developers would know and machine learning analysis. So without us, we never configured any alerts in this Instana application, but it noticed probably much sooner because I was busy answering questions. It noticed that the call volume to one of our services has dropped down to almost 0. And it's alerted us to that. This is a service level impact. So before really we had to debug this, Instana has already told us what the issue is. And it's, if you click on the changes tab, Marco, we might see, no.
Well, I think we can see it in the calls. Yeah, exactly. Just navigate me, Josh. I'm a little bit. I think here it is. So we see here we have an endpoint called upload. That's the normally database endpoint, and we see here that a sharp drop off on the upload endpoint. And we also see here post upload also drop down. This drop down everywhere we see a drop down except for the some automated endpoints. So endpoints called by the infrastructure. And we also see right here, for example, rise in latency. For the delete, we see a rise in latency, and we see a rise in error messages. So this already gives us a little good example of what is going on here. It seems to be related to something on the REST API. And actually, let me show if I can show. Let me see if I can show you this one. If I go back to the dashboard, I should be able to see right here. These parts are red. So here are the messages dropped. And here is the important part. Yeah, you see on the MQP that there are in the total calls, we have a sharp drop off. And that's right here is the information. So we see the REST API is red, the upload is red, and on the IMQP side, we see that the messages are dropped. They are dropped here as well and here as well. And this gives us the indication that it's something down this line here. Yeah. So if we have a little bit of knowledge of our application, we know that if the application throws 500 errors, it's most probably because the database isn't reachable or the MQP isn't reachable. And from this point onward, we can take a look in our cluster. I'm running K9S right here. And we see, oh yeah, look, the Artemis is actually not online. Normally you would see here, okay, the Artemis isn't healthy anymore. And we have to go into the logs of the Artemis or jump to the logs from Instana. I can demo this part as well. So let's go to the flow of this application. Here you can see another feature of Instana. We can say, okay, show me the stack. I'm interested in the actual deployment, the actual pod that's running this application right now. And now I can jump into my ELK stack. So that's an external link to my ELK. I have to do a little foxy-woxy right here to quote this. And now I'm going to see only the logs from this container, and those are the logs. And now I already see, okay, it's reporting a status of down. And when I'm looking here, establishing connection with AMQP broker failed. So this should be visible. Where's the message? Where's the message? Okay. Message. So here it's saying establishing the connection with AMQP broker. So that's also only an info warning log. And this right here, let me see where the warning level, here it is. So here we have the error warning log in the application that actually tells us, okay, message, where are you? You are down right here. Unable to connect to broker, the retry will be attempted. So this is the final information we need to see. Okay, we are unable to connect to the broker. Up here we see the Java component, reactive messaging AMQP. So we are sure it isn't the database, it isn't something within the service itself. It is actually the Artemis that's not playing along. So let me scale up the deployment again, simulating that we fix the issue with our Artemis. This will take a second to boot up.
We just have 3 minutes left. So while we're waiting for Instana, will automatically resolve that issue once it notices the call volume has returned to normal. So while we're waiting for that, are there any final questions?
There is a final question, it looks like, in the Q&A box.
Yes.
Okay.
Yes. So rather than just setting static thresholds, which you can do, if you'd like to set static thresholds for alerts, you can. But the AI understands seasonality and understands time of day, and it understands percentiles. So you can actually have kind of a curve for your ideal band. And when things are out of that curve, that is when alerts will happen.
And another question in the chat. Does it support integration with some chat ops tools like Slack or Teams? So if alerts come up, they show up as well.
I'm gonna have to get back to you on that one.
Okay. Is that really AI using ML, or is it just analytics using seasonality?
No, there is actual ML happening in the backend.
Cool.
The alerting, the manually configured alerts use seasonality, but the automatic and smart alerts are using machine learning. Any other questions?
That's all the questions. And we are at 1 minute.
Okay, then I would jump back to the slides really quickly, go back into presentation mode. And okay, we have already clarified we don't have any questions. At this point,
last question. How are the models updated?
The models. Good question. I'll have to get back to you.
I think it's the ML model, right?
Yeah, that'd be something. Yeah, I'd love to talk to our engineers about that.
Were those all questions?
That's it. So if there's no more questions, that should during the ML ops.
Yep.
Okay.
I agree.
All right, perfect. Well, we are just at time. Thank you, speakers. This was wonderful. And like I said, we will go ahead and upload this presentation and recording on our website and send out a follow-up email. Thank you all so much for joining and have a great rest of your day.
Thank you.